Okay, so obviously Dave Lee. My Twitter and GitHub handle is Castiglione. The title is a bit of a title bait in that I think all reactive cocoa is expressive. I'm not going to be talking about ways to make it more expressive per se. This is a talk that is kind of my take, I guess, on reactive cocoa. It's not stuff that you may have seen elsewhere if you've looked into reactive cocoa. It's not in Ash's book necessarily, or it's not in the reactive cocoa documents. So it's my conceptualization of what of a certain way to come into reactive cocoa. So I'll do three sort of parts to this. So I'm going to start with talking about returns. That's just not the monadic return. That's just like return in any language you know, the simple return statement. So signals, kind of at the core, what they are, and then why I think signals are ultimately expressive. So return is simple, too simple. That's why we have callbacks. So we have target action. Everybody should know that kind of thing. Delegates are more or less target action, just instead of an action selector, you've got a protocol. And then blocks, which are relatively newer, but still perform the same thing where you have some asynchronous result that you need, and you need to be told of how to do that. So this is all covering stuff everybody probably knows. Iteration, it's another form of a callback. Obviously, when you use for loops and stuff, there isn't a callback per se, but there are libraries that, or some of the collections classes have specific enumerators. Then we have more of the same, but used differently, I guess. So notifications in KVO, they still involve selectors and or blocks, but they're a different sort of communication structure where you say you want to be notified, and when that happens, your code gets invoked, even though the code that sort of triggered it doesn't have to know. Even basic functions, they're in a way they're callbacks. There's conventions and defaults. So when you call a function, the function will write its result and jump back to the return address based on calling conventions. But in a way, that's a callback where you say, here's the address. Use the default address for storing a value and jump back to wherever the code is calling from. So when you look at things like that, then sometimes there's more than one return. So when you do a dispatch async, in a way this has two returns. There's a synchronous return, and there's the asynchronous return, which you don't actually, this code doesn't get notified of, but your block is supposed to handle. And so when you look at returns in that way or callbacks in that way, code like this from AF networking, it's essentially got two types of return, well, three potential return values. You call the method, it starts synchronously to prepare the request, but then switches into asynchronous mode, returns to the caller, and then one of those two blocks get called when the request is done. So you start to get this forking of code paths, and it's not clear, it's not explicit. We can see it, but it's not something we necessarily take as an explicit thing. So callbacks, they kind of have a couple dimensions, I guess, whether they're synchronous or asynchronous. And again, an asynchronous method is always kind of hybrid because it has to do something synchronously, return to you synchronously, and then do some asynchronous code. And then when I gave examples of the different types of callbacks, sometimes you have values, sometimes you have completion, sometimes you have an error. So why do we have so many types of callbacks? And I think that's because the return statement that we all use in every language pretty much, it's inadequate. So we have to compose things differently. It's a leaky abstraction, but we kind of never really look at it as such. It's just the way it is that we all accept. So to try to fix it, if we wanted to do that, there's that well-known quote about adding a level of indirection. So we'll try to add a level of indirection to callbacks. By the way, this is getting to reactive cocoa soon. So instead of supplying your callback as input, so whether it's a selector, a block, delegate, whatever, have a method return a callback object. And since things are always better with the name manager on it, we'll call it a callback manager, because it's not an object, or not a callback, it's a manager of callbacks. So now we get to Reactive Cocoa. So I've sort of identified this place for a callback manager, and that's really just a signal in Reactive Cocoa terminology. Other FRP libraries will call them different things, observables and other things, but here we'll call them signals. So Reactive Cocoa, if you go to the Reactive Cocoa GitHub page, you'll see there's some documents in the repo, and the documents have a framework overview document, and it lists probably a dozen different things. When you want to get into Reactive Cocoa, none of those things are really important except for signals at first. You can get into them, but they're ancillary, so they're not important right away. So signals, in Reactive Cocoa, we like to think that they're the grand unified theory of callbacks. So you just use signals everywhere. And I added the line about promises there at the end because Ian talked about promises. Signals are super promises in a way. They can do what promises can do, but they can also do a bit more. I can talk about that in questions after. So now that you have this signal, aka the callback manager, you have to get information out of it. So that's called subscribing or subscription. There's a bunch of different subscribing methods where you can either subscribe to all the types of events that can happen or just certain types of events. So for example, if you're writing a file, there's really no data involved. It's either it errored or completed successfully. Same if you've got some query to some in-data memory, for example, there's probably not going to be an error. You just want the data. So signals are all around, but they're mostly they're not in your business logic. So when you do stuff in your domain, you're probably not going to use signals as much, though you can. But where they're mostly seen is anything that's asynchronous or takes some time. So networking, user input, long-running things like user input, it's a continuous thing, right? When people are scrolling and touching things. The applications have life cycles, there's timers, queries, any of these things can take time. And so they're good situations for signals. Now that we've added this signal concept, what have we gained? If you can use them everywhere, then you've gained consistency, but that's not necessarily worth it in and of itself. But we have refactored for responsibility. So a lot of times when you have a delegate or you have a callback block maybe, you'll dispatch onto some other thread or some other queue because you want it handled somewhere else. But then you're taking responsibility that could be in a callback manager and doing it yourself sort of manually. So there's a bunch of things that you can do that if you say, okay, I've got this signal and it's responsible for delivering events to subscribers, then you can put a lot of that responsibility into one place and not spread that responsibility throughout your code. Signals are time and event agnostic. So what I mean by that is that a signal can be synchronous and it can be asynchronous. So data, when you subscribe to a signal, you can get data right away or it might take some time. It doesn't really matter. You don't have to worry about it because later on we'll see how you can compose signals together. An event, like I said, you don't have to change it if one day now you want an error. So you have maybe add a failure callback to your API. You just have this one consistent API that has time and events sort of built in. And it's a new abstraction. So whenever you add a new abstraction, there's usually sort of a playground where you can discover things that maybe you wouldn't have seen before because you can start to make different pictures. So signals at the core. What can we do with signals? So a signal, obviously it's a callback manager, but it's also, we can start to look at it as a data structure. So signals have 0 or more values, and they end with completion, or they could end with error. So that's kind of like a list. A list can have 0 or more values, ends with nil, something like that. But of course, these are not regular lists because they have other factors such as laziness, being asynchronous, and potentially having errors. But that still means that there's operations that we can do on signals. So you can combine them by concatenating them, you can map over them, you can filter them, divide them up, break them into pieces. It's all basically list operations that, if you're familiar with any kind of functional style list libraries, then you'll know that. But there are other things that we can do on signals that aren't data structure, like that are more flow control. So distinct until changed. You can say, I don't want this signal to tell any of the subscribers about events until the event is new. So if some signal sends 5 over and over again, we won't get notified as a subscriber until 6 comes or some other different value comes. Deliver on, I reference that as something that we all kind of do where you deliver it on to some queue. This makes it a little bit more declarative and moves it from the subscriber or the callback into the signal as a concept. Throttle, that's just, sometimes you don't want, an event might happen a lot, quite frequently, like scrolling or whatever, so maybe you want to throttle it. Delay, repeat, retry. These are all things that you can do that are on a signal that are flow control in a way. Signals can work together. So you can have 2 different signals and you can combine them one after the other. You can say, I only want the value of A whenever B sends an update. You can zip them together so that it's like lockstep. So the first value from A goes with the first value from B. You can combine the latest values even if one gets ahead of the other. You can catch errors and give a new signal when that happens. So there's a lot of signal composition functionality that Reactive Cocoa has. So yeah, that's kind of what I was saying in the last one, where signals, whenever you perform an operation on a signal, it returns another signal. You can just keep chaining them on, and you're always working with a signal. There's also, this is probably getting a little bit advanced right now, but it's still interesting to talk about for anyone who might be a little bit more familiar with Reactive Cocoa. So I compared signals to lists, but you can also have signals of signals, which in a way is like a tree. So as an example, as you're scrolling through maybe as you're scrolling through some images, some GIFs or whatever, there's always going to be a changing set of images or cells, and each of those is going to involve requests to the server to download those images. So you get these nested signals. Nested signals have their own operations, but there's only a few of them. They're similar to, if you want to have an analogy, they're similar to tree traversal in that you can kind of go about going down a tree in different orders. So whenever you have a signal of signals, you can perform different operations on them so that you get the results in the way that fits your app in that location best. Flatten map, there's a flatten operation, and then there's a flatten map operation. So flatten is kind of special, but it really is just conceptually the same as doing a map and then a flatten operation. It confuses a lot of people, so that's kind of why I put it on here. But it just takes getting used to. It's not confusing, you just have to wrap your head around it. Yeah, so signals are like callbacks, but they're also like data structures, and they have flow control. So as a concept, it's kind of out there. Either you think it's great and it's at one end of the spectrum, or you think it's crap and it's at the other end of the spectrum, because it's kind of a weird thing compared to what we're used to working with. So one of the things that happens with Reactive Cocoa is there's a lot of terminology, and it can be daunting at first, I guess, but Git has the same problem, even though object-oriented programming has a bunch of its own terminology. I like to think of these signal operations as the keywords. If you're learning a new language, there's a bunch of keywords that you have to use and a bunch of operators. A lot of the operators are mathematical based, but you're not doing math, you're doing, apps that are for non-math users, right? So basically, accept the fact that you're going to write some stuff that is going to use your domain, but it's also going to require adopting and embracing these operators, these signal operators, and it's fine. So composing and operating on signals or callbacks, it's going to be foreign at first because we're used to just, the more natural way of, okay, here's my callback, now I do some code, and hopefully someone else does their, some other code does its job. But now we have concrete abstractions that previously we kind of just expressed implicitly in our code. There's no real way of chaining one delegate with another. So for example, if you've got an app that's location and map based, you've got your map view delegate, you've got your location manager delegate perhaps, and you want them to interact. But you have to chain that all together yourself kind of explicitly. Or explicitly, implicitly, I guess, is as you might look at it. So signal operations and composing signals, it's kind of this weird thing to explain. But if you've ever written a delegate or a callback that doesn't want to do any work until the value's changed, and you check to see if your last cache value equals the current value, and if so, you return, then you've written an implicit distinct until changed operation. Same with throttle. Sometimes you don't want your location delegate, for GPS updates to be overworking. So you check to see, when the last time an update came, and you discard it if it's been too short of a time. And again, deliver on, which is a pretty common one that we do with GCD all the time. But these are just the start. They're kind of basic ones that we've all done, but they're just the starting point. There's a lot better ones that you can get in Reactive Cocoa, and it just takes diving in and getting used to it. So when Leonard told me that this was going to be Expressive Objective-C night, I thought about Reactive Cocoa, and I meant to ask this at the beginning, but how many people have worked with Reactive Cocoa? Or at least seen Reactive Cocoa code, let's put it that way. So if you've seen Reactive Cocoa code, I'm going to bet that most people would leave their hand up and say that it doesn't look expressive, because it's not natively expressive. It looks funny, it's got weird words, so. But I do think it's got an expressiveness that is hard to come by otherwise. So when you think of expressive code, I think Ian talked about some of the things that you would normally think about. I can't remember what the 3 items were, but usually it's in thinking in the small. So expressiveness in the small. But what does expressiveness look like in the large? So there's this thing about, good programmers can keep all the code in their head, but I think that's a code smell, and I think other people would agree. The more complex your app is, the more you have to juggle in your head, the tougher it is to write quality software. And I think some of this is due to typical object-oriented design that we work with all the time. Everyone will have their own opinion, I guess, but does object-oriented design reduce the amount that you need to keep in your head, or does it increase it? So I think there's an OO hell. Callback hell is recognizable because we see wide indentation way off the screen. But OO hell, it's hard to know, what is that? Like, if it exists, which I think it does, what is it? To each their own, maybe you'll see it differently. But it's kind of like this game of where's the ball, right? Like, you've got to watch all these moving parts and know exactly where, the state is, right? You don't know the state. And then if you scale it some more cups, it gets even more challenging. So, and there's maybe multiple balls flying around, and you're going to lose your money. So I think object-oriented design pretty much requires perfect communication from all the components involved. If one component fails to notify another or fails to observe another, then that's where you get bugs, and it's hard to remember all those pieces that need to be notified. And it just gets harder as code grows big. Like, it's easy to do a small app, but when you get really big apps, human nature and OO combine for shitty structure, I guess. Because we always have, everybody knows the big classes, big methods, we've all seen it. So is it that we're doing OO wrong, or is that OO is a mismatch for the communication structures? I think some of the stuff we do, like delegation and specializing, we do it as humans, and that's fine, but is that fine for software? So expressiveness. We need a new way to communicate compose communication structures. So when parts of your app are communicating with each other, how do you compose that structure? I've said that OO I don't think fits the bill, but now we have signals, which I've talked about, and they're kind of a new way to communicate because they can compose with each other. They have these operations. They're kind of like data structures. So let's try those. Sorry about the code size. I'll try to read it out so everyone can see it. So this is a kind of stereotypical reactive Cocoa example. And basically what it is a sign-up form, which in this case has a first name field, a last name field, and 2 email fields. If you were to do this with events and off those text fields, you'd have code somewhere else, and you'd have to check to see which field it was, to see whether to assign it to a first name or assign it to a last name, and then rerun a computation. So in this case, we're combining 4 signals. So the text fields, as the user's tapping away, those are going to change. So we've got this combine latest operator, which takes an array of signals, and every time one of those signals send a value, it composes it and passes it along in the chain. So in this case, as each of those text fields change, this reduce method is going to get called, which is kind of like a map. You can consider it the same. And all it does is check to make sure all those values are entered, because we don't want a form that's partially filled out. And then it compares that the email addresses are equal. Up here, there's this macro. It's called rack. It's kind of not the greatest macro name, but don't be afraid of macros. This one just named poorly. And so we've got a submit button, and it has the enabled property. And what this does is an implicit subscription. Sorry if I'm blocking it for people over here. It does an implicit subscription where as those signals change and as they get filtered through this reduction block, we get a Boolean. And that sets the enabled field on the submit button. So once all those fields are entered and the email addresses are identical, now your submit button is activated. The advantage with this is that it's all, like the code is local. You don't have to go seeing, who's the delegate or who's the, target action, or, you don't have to go elsewhere to see who's responding to things. You can take that code and plug it in anywhere almost, because obviously these are properties on your view controller or whatnot. But it's a self-contained piece of code. It reads from top to bottom. Once you get to know these keywords in Reactive Cocoa, it's actually really clear. So here's a little bit more complicated example that's not, I've got some awesome rendering going on up there. So this isn't your typical example. So imagine you've got an app that's showing your friends nearby, and but when you're moving, your friends might move, but we're not going to factor that into this one. But when you're moving around, the friends are going to change. So you need to do a query to the server and say, okay, now who are my friends nearby? So again, this has the advantage of there's a lot of code. It reads top to bottom, but it's all here. There isn't this OO structure where you go look at other objects that are delegates and look at callback blocks. It's all right here. So what we're doing here now is we're saying whenever the location manager gave us new updates, we're going to throttle it. So even if this happens more than once a second, if we're moving really fast, there's no point in querying the server more than once a second. So we're throttling it to once a second. Now we're going to map it. We have an array of locations. All we want to do is take the most recent location, which is the last object. And we also don't want to redo a search if you've changed your location just slightly. So there's a bit of math here to sort of round the lat long and produce a new location. Here's the distinct until changed operator I mentioned before. So since we're doing some rounding, you might move slightly, you might get an update, but if it hasn't moved enough, then it's going to get discarded because we've sort of rounded off some of the precision. Here's flattened map. That's kind of a core part of signals. And what's happening there is now that we have a location, we know it's not too frequent, we know it's a relatively significant change, we want to query the server. So we've got some API client, we call some method saying, search for my friends nearby this location. But this method also returns a signal. So if this was just a regular map, then we would have a signal of signals. But we want the values out of it. So we flatten that from signal of signals to just signals of values. This method returns a signal that sends arrays of friends. And again, here you have the rack macro, and it's assigning that to your friends nearby property. And after all of that, we have this imperative action that we need to take. We need to take the table, tell the table view, reload the data because we have new data. Of course, you could do it nicer where you've got some deltas between your friends lists, and so that you're animating things in and out, but that's not for this example. Again, going from top to bottom, we're taking input from a delegate method, so that's the OS or core location library framework giving us some input, and then at the end, we're telling, again, a library that's not ours, UIKit, to reload some data. So we've managed to go from one end to the other and kept all that code in one spot. That I see as an advantage. So Reactive Cocoa, it's going to be ugly if you haven't seen it before, but it has a new kind of expressiveness. Whether you think it's an expressiveness that's right for you, I don't know, but there's a lack of there's a missing component in what we do today. So the idea of this talk was to talk about concepts as much as Reactive Cocoa. So if you don't like Reactive Cocoa, then that's fine, but there's ideas here that, for ways to express how you do computations, how you design your app. And so I think that's what is the key point from this. So in closing, if you want to get to know Reactive Cocoa, there's lots that I haven't talked about, and I can talk about after if anyone wants to chat. There are lots of pitfalls. Excuse me. The stack traces are awful, like really, really bad. I don't think you realize how bad until you see them. You can do things like forgetting to subscribe. So one of the things I didn't talk about with signals is they represent a deferred computation. If you don't subscribe, then nothing happens. So there's an advantage there because I talked about retry or replay operators. You can have a deferred piece of work represented as a signal, and then you use the retry operator on it, and if it ever fails, it's just going to retry because it's not like a promise is. It's a one-time thing where it happens and it gets a result. This is a representation of an action that can happen over and over again. If you have a signal and you subscribe to it twice, that's going to cause two things to happen, not get the same data twice. And so as I said, if you subscribe twice, you take that action twice, so you might accidentally hit the server twice when you're first learning this. So there's some replay operators, but they're good and bad. They can add complexity, so they're not really encouraged, but they're not yet deprecated. So you start to get into some hairy, well, maybe not hairy situations, but situations you have to pay attention to semantics a little bit more closely. There aren't great documentations for Reactive Cocoa. You have to use the headers. And then, of course, there's lots of learning, if nothing else, just the terminology involved and the semantics of it. But if you do get started, don't worry about having some code that's Reactive Cocoa and some of it that's not. It's impossible to avoid. We all, if you're writing a rack app, you still have lots of non-rack stuff to do. It's just the nature of it. But Reactive Cocoa, if you do go down that, go to GitHub, file issues to your heart's content. There's kind of a philosophy of wanting to help anyone with any issue if you have a bug with the framework, or if you just can't figure out a bug with your own code. It's a really good place to learn. Basically, it's like free rack lessons and it's a built-in philosophy. So it's not like you're not going to be troubling people. So that's it. Thank you.
It seemed like that one of your, let it be said that I do write modern Perl, so I'm familiar with the O nightmare.
Okay.
I'm currently living in it.
Yeah.
It seems that one of your kind of major claims is that the advantage is that the code does in fact read top to bottom and flows from one action to the next in a waterfall and is all written locally.
Mm-hmm.
Obviously, this has the advantage over, say, having to hunt down in what delegate library is doing what. But it seemed that kind of the naming convention that Apple attempted to give people with Objective-C was the idea that your O was supposed to describe what it was about to do. That those interfaces should be transparent. That I don't have to look at what it's doing. I can expect that a library is actually doing what it says it's going to do.
Mm-hmm.
Do you feel like that paradigm is just something that people aren't capable of following? Or do you feel like that when it comes to callbacks, that's not possible?
I think it's just, it might be discipline. So, discipline it is what it is, right? It's, some people, some organizations are more disciplined about the code that they produce and, following guidelines like that or following best practices or making their own things like that. But I just feel like that waterfall that you kind of described of composing in a linear fashion is easier to reason about, and people do it anyway, right? We get these big long methods and big long classes where it's like, oh, where does this go? It's like, okay, I need to add this code. Who's got to do it? And the bigger the app gets, the more classes that are involved. And oftentimes people just stick things in, the view controller, or they stick it wherever other code is or wherever it's most convenient and easy. And so I think that's just kind of the nature of both humans and then kind of OO, right? Like you want the easy way. You don't want to have to go figuring out all the players involved. It's kind of like human organizations, right? It's like if you deal with a big organization, a government or a big company, it's like you don't necessarily know who the right person is. So you just ask anybody you know and kind of try to go from there. And I think code's often the same way. It's like, where can I put this in just so that it can work out, rather than figuring out the right person in this big communication structure.
Okay.
Yep.
So I'm kind of like an outsider here because I come from a Rails background.
Okay.
And we have something called callbacks in the active record models, and
right.
kind of a similar thing. You subscribe to an action, and you have something you do because of the action. You definitely don't have the same top to bottom reading, which I like about this. What scares me about reactive Cocoa is this ability to unintentionally react to things in a way that you didn't expect. Like I've had this happen in Rails a lot, where you have a callback, after save or whatever. You're doing something else, you're saving over here, and it's doing something on the other side you didn't intend because you subscribed to it.
Right.
Is it a fault?
It's not something that
It's
not something I've personally found. The difference between I think that and signals here is signals here are kind of this simple abstraction, so there isn't. It's a different way about going about it. So in this case, you have a signal that it can send some values, or it can complete, or it can send an error. But there isn't this idea of here's some object I want to observe when save is called. So it's kind of like, I think the difference is that you're not observing pieces of an object outside of its knowledge in a way. When you work with reactive Cocoa, you start to expose signals. Although there is a lot of elements where you can observe an object without its knowing you're doing it. But yeah, I think it's not something I've run into a lot myself, and I think there's a lot less things that can happen on a signal. It's going to send some values. It's going to error, it's going to complete. There isn't a lot of complexity on a signal. But like I said, debugging is hard. Sorry, go ahead.
Are signals generally long-lived, or are they something that you subscribe to and then like unsubscribe to, or the signal is like ephemeral?
Yeah, that's a good question. They can be either. So a signal could send a single value, or it could be sending values over and over again, right? If you're watching the scroll view, it's going to be something that the user could do a lot of, but a network request, it's just one, right? So it could be really short-lived. So if there's no prescribed length, you have to kind of know that with the object you're dealing with. There are operators such as take, which you can say take 1, take 2, whatever, and you can just get a couple values and then it'll end the subscription. That's it?
Sorry.
Oh, okay, I couldn't see.
It's hard to see back here.
Yeah.
It was about your code example with the map, the CL location stuff.
Yep.
I think I was confused because I think it's the argument to the block is a set of locations, and then you use one. So is the map's not across the locations in that case. You're doing a map function across signals over time, basically, and each time there's a signal that goes through that block, basically. Is that?
Yeah. So that signal sends an array. Right. So and then I wasn't mapping over the array.
You're taking the last one in that block and doing something with it, and then the next time there's a signal. So that's what map does, is it's kind of always open in a sense, because there's new signals coming in?
Yeah, so yeah, signals are data over time. So yeah, every time the location manager sent a new array of locations, that map block gets called. And in this case, it's an array, so it takes one object out of that array, but it's not mapping over that array, it's mapping over the signal. So a signal could send a single item, it could send a collection like an array, it could send a model, a dictionary, whatever. It can send any value.